In this video, we'll generate the polynomial regression of a cosine function using LINEST and matrix solution. We begin with generating the dataset of the cosine. So array formula of the cosine x values. And here we have the trend line of the cosine. And the trend line polynomial of the cosine to the fourth degree, which is 1 plus 0.414x minus 1.14 x squared plus 0.339 x cubed minus 0.0269 x to the fourth. Next, we use the matrix solution, which is we begin with the 1 comma x matrix, which is array formula of the x values raised to the power 0 to 4. And we calculate the P-Gerina inverse, which is equal to minverse. That's minverse. M transpose of the 1 comma x matrix and itself. And the P-Gerina vector, which is equal to M transpose of the 1 comma x matrix and the y values, which is cosine of x. Now we can calculate the regression coefficients, which is equal to M of the inverse, the P-Gerina inverse, and P-Gerina vector. So here we have the regression coefficients. So we have 1 times x to the 0, which is 1, 0.414x, which is 0.414x, minus 1.14 x squared, minus 1.14 x squared, plus 0.339 x cubed, plus 0.339 x cubed, minus 0.0269 x to the fourth, minus 0.0269 x to the fourth. We can use LINEST. So this LINEST data y and data x. Here you have the coefficients. That's 1 times x to the 0, 0.414x, minus 1.14 x squared, plus 0.339 x cubed, minus 0.0269 x to the fourth. This completes the use of LINEST, ARRAY formula, and the trend line, the charts, the scatter chart to generate the polynomial regression of the